Protoplanetary disk formation is a complex process. It begins with a spinning cloud. So when a very large dark molecular cloud collapses and forms a relatively small cloud core, the rotational energy is confined to a much smaller volume. And this causes the smaller cloud to spin much faster, just as when a figure skater draws in her arms and spins faster. There's 3 stages to disk formation. First, the disk begins to form as material in the cloud falls towards the midplane and the sun. Second, the disk atmosphere is blown away and the midplane thins. And third, planets form in the midplane and form gaps in the disk. This is a side view of a young disk, and extreme ultraviolet radiation ionizes the hydrogen gas in the disk and dissipates the disk first close to the star and then far from the star. And then particles of ice and dust fall to the midplane by gravity. So the midplane is the low point, the gravitational low point, and also the sun is a gravitational low point. So that means that particles fall towards the disk and move towards the sun. This is an artist representation of a young protoplanetary disk with the disk thin near the star and thick far away from the star. Much of the star's mass enters from the disk. The material first falls into the disk by gravity and then is attracted to the sun by gravity. Centrifugal force would push it out, but viscosity in the disk causes the material to lose energy and fall into the sun or star. So the disks become hot, high above the midplane, and cold near the midplane. And due to the different types of radiation, some complex regions become set up in the disk. And actually, the supernova that triggered the formation of our sun caused a lot of ionization in the disk. When stars are in dense stellar nurseries, such as starburst clusters, the radiation from large stars can dissipate the disk. This is why it's a problem for the sun to have formed in a starburst cluster. We can find evidence for characteristics of the circumsolar disk in the planets. For example, there are small terrestrial planets near the sun, Mercury, Venus, Earth, and Mars. And then there's large gas and water giants in the outer disk. So planetary scientist Avi Mandel conceived of this image of the early circumsolar disk, where it's thin near the sun, so this is where the terrestrial planets would have formed, and it's thick far away from the sun, which is where the gas giants formed. One thing you should realize is that the planets are very small and widely spaced with respect to the diameter of the disk. For example, here's a representation of the size of the sun with respect to 1 astronomical unit distance in the disk. And then we can't even see the size of the sun, and of course not the planets, if you look at the entire radius of the disk, 30 astronomical units. So the disk was initially large in comparison to the sun, but Adams calculated based on the mass of the planets, the disk mass was only 3.5% of the mass of the sun at the time that planets formed. And disk diameter was probably 30 astronomical units at the time the planets formed, since the outermost planet, Neptune, is 30 astronomical units from the sun. And the Kuiper belt is probably composed of small objects, which is outside of Neptune, thrown out of the solar system by the large planets. We'll see you next time.